All right, our first bit, we're going to look at the parts of the atom. So you want to make sure that you're comfortable with these definitions here: protons, neutrons, and electrons. And then we have two: mass number and atomic number. So mass number is the number of protons plus neutrons. So that's going to be important for us: protons plus neutrons. The atomic number is going to be the number of protons, and this is going to determine the name of the element. So the number of protons gives us the identity of the element. All right, here we have just kind of a key how to find this. The top number is our atomic number. So protons, it's the same as the atomic number on our periodic table. That's the number on the top. If you look at your periodic table, it's going to show you atomic number along the top, element name, and then mass number along the bottom, simple. So this will show you kind of where these two things are. So atomic number, and then the second one is average atomic mass. Okay. When we talk about mass number is going to be a little bit different. The number at the bottom is the average atomic mass. So to find the mass number, we're going to round this. So we can say that for this one here, our mass number is going to be equal to the number on the bottom. So 78.96 is going to round to 79. Our atomic number, so our atomic number is going to be given up top. So we have 34 here. So these are the two numbers that we're looking at. So if we were to find the number of neutrons, we do mass number minus atomic number. So mass number, 79, minus 34, will give us our total 35 here. Okay, lastly for electrons are going to be the same as protons for a neutral element. So let's look at a couple examples of these. Okay, the first element that we're going to look at, boron's already completed for us. So if we look at boron on our periodic table, we can see where we got this information from. So boron on our periodic table is going to be element number 5. So let's look at the information they give us for boron. Okay, first off, the name for boron, we have our name here along with the symbol on the top. So the element symbol is the letter that represents us. There are always two letters. First is always, there's sometimes two letters. There's always one capital letter, and the other ones, when there's two, we can see a lowercase. So if you ever see a lowercase letter, you know it's part of the same element. Okay, mass number and atomic number. Our atomic number is given to us for boron. The atomic number is going to be the number at the top. The mass number, we're going to round. So this is 10.81. We have 10.81. We rounded this. So we got that 11 from rounding up. 10.8 rounds to 11. So we round to the nearest whole number. Okay, atomic number was the number on top. And then the nice part of this is the atomic number, protons, and electrons are going to be the same. So the atomic number is equal to the number of protons and electrons. So we can kind of write that up top. Atomic number equals the protons and electrons. And we're going to say for neutral atoms. Later on, we're going to see that this isn't true for ions. Ions are when they are different, but if I give you something from the periodic table, we just say that they're the same. Okay, lastly, for neutrons, what we did was, to find the neutrons, we did the mass number minus our atomic number. So here I did the mass number of 11 minus the atomic number of 5, and that gave us 6. So that's where we got our 6 from. All right, and then we can look at a few other ones for this. So let's look at sodium. Sodium is the name here. So the symbol is going to be Na. So we'll take the two letters for sodium. We'll write this out. For sodium, they already gave us the mass number. So if we notice here, this is 22.99. If we round this to 23, we're going to see that these two don't match. And that's okay. So sometimes with a mass number, they give you a different mass number. It's what we call an isotope. Isotopes are when you have different mass numbers but the same atomic number. So this number may be different. If it's not given to you, we just look at our periodic table. We can find it there. Okay, the number of protons is simple. Protons and electrons are equal to our atomic number. So we know the atomic number is 11, so that's 11 protons and 11 electrons. All right, to find the number of neutrons, we're going to do the mass number minus atomic number. So mass number minus atomic number, so 24 minus 11. We would subtract these two, and we should get a total of 13 for this one. All right, let's do an additional one so we get one more practice down. Okay, we're looking for element Y. So element Y on our periodic table is down here. It's yttrium. It's element 39. So we're going to take that and write the name of this. So YT TRIUM. And if you see weird names for elements, a lot of them are borrowed from foreign languages. So this comes from a Scandinavian language. Okay, the atomic number for this one, we know that our atomic number is the number on top. So 39 is our atomic number, so we can put the element 39. Now that we can see this, the number of electrons is the same as the number of our atomic number. So electrons, atomic number, and protons are always going to be the same. And then lastly, to find the neutrons, we're going to take the mass number and subtract our atomic number. So 89 minus 39, we're going to get a total of 50. So this is just figuring out, using our periodic table to find number of protons, neutrons, and electrons given different elements.